Hello, I'm Grant Graydon, and since there's no one around in tutoring right now, during the class time, I'm going to take this time to make some videos for you guys to try and help make your lives a little bit easier if you just want to watch on YouTube. So, here, I'm going to show you my personal preferred method for solving systems of equations when I'm on a computer and I have access to MATLAB. I find MATLAB to be a lot easier to solve this compared to Symbolab in the long term. So the way that you want to do this is for a system of equations. I just wrote up a very simple example here. So this is a 2x2. So you've got, in this problem we're going to assume that all of our constants are known and we're looking for what x and y are equal to. So if I remember right from my differential equations in linear algebra class, we can write this right here, ax minus b equals 0, which becomes ax equal to b. Now, we just need to figure out, first off, what everything is in this equation. I promise it'll be a lot simpler once you figure this out. Once you get it, it's really easy. So b, what's b? B is the easy one. In this notation, b is just the right-hand side. The constants on the right-hand side, what it's equal to, that's just b. Now, ax. It's a little bit trickier, but still pretty easy. If you just want to look at it to do it really fast, we can just look at this left-hand side here, and in the notation of this equation, your constants in front of the variables are always going to be a. So that means a is equal to c1, c2, f, and g in this example. And a is always going to just be those constants that are in front of it. And it's going to be the number of variables you have and the number of equations you have. So remember, you need to have, if you have x and y, those are two unknown variables. So that means you need two equations to solve, and they need to be two unique equations. So once we have that, x becomes very easy. It just might be a little bit confusing to know that a is equal to those constants, but then x becomes very easy. X is just going to be equal to, in this case, x and y. Now, if we were to rewrite that ax equal to b into the format we're looking for, it should make a little bit more sense. So c1, c2, f, and g multiplied by x, y is equal to c3 and h, which is our b. Now, if we just do some really quick vector multiplication to prove this, c1, c2, xy, that gives you c1 x plus c2 y equal to c3, and then we do that for the lower half with fg and xy. What do we get? Well, we get fx plus gy is equal to h. So if we go back up and look, that's exactly what we have. So we know we wrote it in the right format. This is just proving it. You don't need to do this every time. This is just trying to help give you a better grasp of where this comes from. So I'm going to erase all this. Except for what we know down here. So we know what all these are. So how are we going to figure out what x and y are equal to from this? Well, it's pretty simple. You can't divide by a matrix, but you can invert it. So we're going to rewrite this in the form of x is equal to a to the negative first b. And it's very important, if you work on this, it's very, very, very important that this a has to come before the b when you're multiplying. You can't just do b times a to the negative first. That will not work, and I believe MATLAB will actually throw an error at you if you try and do that. So it's very important that it's in the form of a to the negative first times b. So I'm not going to go over how to invert a matrix because that would be a lot of math to do by hand. So instead I'm just going to show you how to work in MATLAB to do this for you because it'll be a lot easier. Now there's also other methods kind of related to this that you could use on a test if, let's say, your professor didn't want you to use even a calculator that supported this kind of stuff. You could just use Cramer's rule if you remember that from your math class, though admittedly I have never had to use Cramer's rule on a test. But it is a thing just to be aware of if you want. Now, for MATLAB, how to do this. It's extremely simple. It's extremely simple to do. So, if we go back up and we look over here, we can see this is what we have, right, for our system of equations. And we figured out what a is from this, what x is from this, and what b is. Now, really, you don't even need to write this down. You can just look at it and really pretty quickly pick up, oh, okay, C1, C2, FG, that's A. XY, that's X. And then, oh, the right-hand side here in this form, that's B. So, why don't we say, for this problem, that, because the thing with MATLAB, though, is that you do have to know the values of each of these to do this way. You need to give it actual numbers rather than variables. So for this problem, let's say that C1 is equal to, let's say, G is equal to 2. And let's say that C2 is equal to 1. And let's say F equal to 3. C3 is equal to -1. I'm just picking completely random numbers here. I honestly don't know if this will work or not, but I'm pretty sure this should. And let's just say H is equal to 0. Alright, so what does that give us if we look at our form from above here? That would give us the equation, just picking these random numbers, of 2x plus y is equal to -1, and it would also give us the equation 3x plus 2y is equal to 0. So, just looking at this, let me double check. Yep, okay, I believe I put that in there, right? Just looking at this, we can see that A is equal to 2, 1, 3, 2. And B is equal to -1, 0. And then, like previously, x is equal to x and y. And we're looking for x. So, all we have to do in MATLAB is plug in this A and this B. And you honestly don't even need to write a script for this. You can just work in the command window. It's so simple. So, to put in our A, I'm going to just do it in a script because why not? we're going to say 2, comma 1, because in MATLAB when you put a comma, that's working across the columns, and then semicolon drops you down a row. So 2, comma 1, 3, comma 2. And that will give us the matrix for A, and then B is equal to -1, semicolon 0. And then all we're going to do is A to the negative first times B. And this will give us X and Y in a 2x1 matrix. And there you go. We have found our answer. X is equal to -2 and Y is equal to 3. And what's so great about MATLAB is the fact that you can work through this, and all you have to do is just put the numbers in here and here, and you can work with as big or as small of a matrix as you want. A 2x2 obviously being the minimum, and a 50 by 50 is definitely doable in MATLAB to solve for this. Alright, so I hope this helped a little bit. Good luck, and I hope to see you guys in the Zoom meeting or in person in the future.